Robotics, autonomous systems, and artificial intelligence, or RAS-AI, will introduce game-changing new capabilities for Australian defence. Defence has identified trust as one of the 5 facets for ethical AI, because trust will play a significant role in how these technologies will be used. This video is part of a series on these facets, which are responsibility, governance, trust, law, and traceability. In this video, we will explore trust in RAS-AI from the perspective of defence personnel, using case studies from Army use of unmanned ground vehicles and a fictional scenario called striking blind. Trust is a belief in reliability or ability of someone or something. It is vital for the adoption of any technology. For RAS-AI, trust will exist where the actions of systems are coherent and justified. Trust requires hands-on experience in training and exercises to make sure our people and machines are trained and prepared for real-world scenarios. In the Australian Army, Major Chris Hall has worked on trials that use robotic vehicles and unmanned aerial systems. He is examining the best ways to prepare future Army leaders to work alongside machines and looking at human-machine teaming more broadly.
I've been convinced that these systems are the way forward in achieving increased lethality and protecting our own people. It will be very difficult in future for a human-only team to match the lethality and the tempo that can be generated by a human-machine team.
In the Australian Army, Corporal Lachlan Jones is working on developing robotic and autonomous systems. As part of this work, he developed an app for a system that helps soldiers send reports.
I'm Corporal Jones. I'm a member of a support company working in 1RAR's innovation space. So for the last 12 months, I've been working on photogrammetry and point cloud data that can be generated and disseminated on the tactical edge of the battle space to enhance our section commanders' level of awareness. Through the production of 3D models and the information generated through it that can be disseminated on the battle space to enable section commanders greater situational awareness.
Defence personnel are now working on how these technologies can be safely integrated into human-machine teams. However, before we use robotics, autonomous systems, and artificial intelligence, we need to establish a baseline of trust in these technologies so that commanders and operators can be confident that a system will perform as expected and in line with governance requirements. This will help defence personnel ensure their own legal and ethical obligations are met. Trust or knowledge of the reliability of the technology is therefore essential. At the Australian company of Athena AI, trust is a central component to the technology they develop.
I'm Stephen Bornstein. I'm the CEO of Cyborg Dynamics Engineering, and I'm the Managing Director of Athena Artificial Intelligence, which is a spin-out AI company initially created through the Justified Autonomous UAS project within the TASD-CRC. My personal background, I've spent 10 years doing research and development in the robotics, AI and defence engineering space, working for BAE Systems, Electron Launch Vehicle at Rocket Lab, Airbus, helicopters for MRH-90 entry into Special Forces, and now with Cyborg Dynamics. I'm also an Army Reserves infantry officer as a reservist. Spent 5 to 6 years doing that as well. We do artificial intelligence to support lawful targeting on the battlefield with rules of engagement for human-in-the-loop operations, and that works with ground robotics, air robotics, all the way up to strategic level assets. I think it's the most important thing for us. It's very easy to produce a artificial intelligence detector, and then you can combine that detector with a camera and you'll have some sort of result. But how do you know whether you can trust that footage to actually only send the detection off the battlefield? Well, you need assurance. Assurance is associated with trust, and we need to consider how we actually do that.
In the 2021 Perry Group paper, Striking Blind, the story considers the opportunities and limitations of military artificial intelligence and autonomous systems. In this story, human operators became conditioned to trust the decision-making system with opaque algorithms, which was implemented after a limited review and limited training for commanders and operators who lacked sufficient knowledge around the reliability of the system. Striking Blind illustrates why trust requires full knowledge of a system.
Sean Hamilton. I'm a pilot with experience on Super Hornets, Classic Hornets, and a little bit of time flying remote piloted aircraft. Our story was striking blind, and our sponsors from Army Headquarters wanted us to explore the impact of trust in autonomous systems. So what trust looks like, how you develop trust, and the impacts of having an inappropriate level of trust, either too much trust or too little trust. The striking blind story is about the ADF putting an artificial intelligence system called Mandela into service. Mandela, think of a room-size artificial intelligence system. Theoretically, it's a decision AI, so it helps commanders make targeting decisions. In our story, it was developed by the United States to fight a high-end war against China because the high-end conflict decisions were so rapid and complicated that humans weren't able to make them appropriately, so they fielded an AI. Australia bought that AI under pressure from the United States, with the US highly recommending that Australia purchase the AI and put into service to facilitate integration and interoperability in coalitions. In addition to that, Australia was doing modelling, looking at the likelihood of success in a war against China, and realised that they would be at a significant disadvantage if they didn't purchase the AI. So there was a lot of pressure to go ahead and field it. Fast forward, our story is not set in a high-end war, it's set in a low-tech separatist conflict in the Philippines, where we're assisting the Filipino government re-establish control over areas of territory. Mandela AI is there with the ground force commander, and it's helping identify targets using all-source intelligence so that we can engage threats to friendly forces more effectively. It allows us to get greater speed in decision-making, greater accuracy in decision-making. The AI is, in its targeting recommendations, is assessing distinction, proportionality, necessity, humanity, and also the national rules of engagements and caveats.
Striking Blind is a story centred around a crew of a Super Hornet, which are airborne over the Philippines, escorting a Filipino Special Forces patrol located on the ground. The Mandela AI is working alongside the crew, monitoring for hostile people.
The Mandela AI is just recommending targeting suggestions to the commander, and then the commander on the ground as the target engagement authority is ordering the strike. So he goes ahead and orders the strike. 32 enemy fighters are destroyed on the ground, and the Special Forces patrol is protected. That engagement's a success. The fighters are then re-rolled to a second engagement, a bridge 7 kilometres to the south, where our sensors have picked up 7 technicals on a bridge, which Mandela then deems hostile because they're an imminent threat to the Special Forces patrol. The AI thinks that they're about to step off and commence an engagement. The commander gets that decision. They attempt to get eyes on those vehicles, but due to low cloud, they can't. So ultimately, commander weighs the risks and accepts the Mandela engagement recommendation based on it being an imminent threat to the friendlies. Weapons are dropped through the cloud, and at the time, successfully destroy the technicals. The story fast forwards 4 years. It has now come out that that engagement was a failure, and it was 1 technical on a bridge that was a checkpoint stopping civilians fleeing a village, and the strike killed 92 people and injured another 100 or so.
The story of Striking Blind was created to illustrate the risk of trusting a system which is not fully understood.
I'm Dominic Tracy. I'm a Logistics Ordnance Corps Major, specialising in fuel, and then I was involved in the Perry Group paper Striking Blind, which explored AI and its introduction into the battle space. So the Perry Group was an initiative under Major General Ryan within the ACSC to look at future concepts and explore that through science fiction. So it was a way to engage more readers and introduce problems that may not interest people on a day-to-day basis. So within the AI system of Mandela that we had for Striking Blind, it had the standard kill chain process over the top of it with a human in the loop at the final end to decide to engage a target. What it lacked was some of the fidelity in its introduction into service, where it was rushed into service to meet a capability gap that was generated through near-peer competition at the time, and that because a robust introduction to service didn't happen, some of the test cases that should have been explored further to tease out risk weren't done, which then leaves decision makers with a gap for how it should be mitigated against, or those risks should be mitigated against.
Human in the loop refers to people working with a RAS-AI system to change the outcome of an event or process. In the story, the human was insufficiently trained in the use of the system and does not understand its limitations.
My name is Beck Marlowe. I just finished Staff College, and as part of that I did the Perry Group option. We were looking at AI as part of our Perry Group module. So not all of the testing and verification had been completed on the system by the time it started to be used as part of our paper. So that was what we were looking at, was what happens when you don't go through the complete process in order to introduce a system into service or start using a system before the full introduction into service. So we did have a human in the loop. So the targeting officer on the ground was the person who, in the end, made the decision on whether or not the AI had made the correct decision. And in this instance, with a lack of other available data from other feeds, because we were in a denied environment, they trusted the system because it had previously been correct, and they trusted that this time again, even though we didn't have all the feeds, that it had the feeds and it was correct, and therefore allowed the system to identify and then fire on the target.
The catastrophic mistake made in the striking blind story prompts a review into how the system was used and relied upon by the Australian Defence Force.
There is now an inquiry into how exactly the ADF got into this position where we're just taking recommendations straight out of an AI, largely without questioning them in too much detail, and this is resulting in significant collateral damage. That investigation in the Senate turns out a range of issues. So it covers off on why Australia bought the AI in the first place, like they were pressured to put it into service due to interoperability reasons and maintaining a combat effective force. They would have liked to have had a greater understanding on how exactly the AI was processing its decisions, but they were prevented from gaining a really high level of understanding due to international traffic of arms regulation, preventing information flowing to Australia, intellectual property rights, but then also technical limitations in figuring out how exactly an AI that's doing machine learning is actually making its decisions and then adapting its decisions. The last problem that they came to is that they put Mandela into a semi-automatic mode where it was recommending engagement decisions to a commander and the commander was making the decisions. And so the human was in the loop there to try to mitigate the risk of having an AI engaging targets without the human in the loop. But what they'd found is because Mandela was so successful so often and had recommended successful engagement so many times, the human in the loop, the commander, had now become conditioned to trust it. When presented with that scenario where he's told that there's 7 technicals on a bridge and they're an imminent threat to the friendly, Mandela calls them hostile. Mandela has called a lot of things hostile in the past and it's proved successful. Why would he not take that recommendation? It would be unethical for him to not act on that information because of the imminent threat to friendly forces and the balanced probability that Mandela's got it right. So having the human in the loop was completely ineffective. It wasn't generating the risk management that the ADF wanted because the commanders had become conditioned to trust it. If they weren't in the loop, it would have had the exact same outcome with Mandela autonomously recommending the engagement.
Striking blind is a useful illustration of why trust with verification is vital when it comes to acquiring and deploying RAS-AI. To be trusted, RAS-AI needs to be safe and secure. It must operate reliably in accordance with its intended purpose and must provide a useful level of transparency and explainability. We must make sure the RAS-AI is trusted, ethical and transparent before they are brought into service. As Chief Defence Scientist, Professor Tanya Munro is Head of Defence Science and Technology Group, DSTG, and Capability Manager for Innovation Science and Technology within the Australian Department of Defence.
We've got a number of layers we need to worry about. You know, human in the loop, human on the loop, and humans out of the loop. They're all different levels of automation. The way we get trust is through transparency and verification. And one of the key focus areas for this work has to be delivering methodologies that are agreed and accepted for delivering that transparency and verification. What information do we as humans need to see from our AI algorithms in order to get that confidence that the data is producing meaningful outcome? It's interesting because when we reflect on these 2 core foundational principles of trust, it actually makes you reflect on what you need to do to drive the whole AI enterprise for defence. Because we know that to deliver some of the asymmetric advantages and to get humans out of perilous situations, we need to work very deeply with industry and with academia. But we can no longer set some requirements and sit back and wait for industry to deliver an outcome. What we really need is to work in deep partnership to make sure the principles of transparent, verifiable AI are threaded right through, both from concept development, when we generate knowledge through our academic partner work, through to the delivery of solutions and products that our commanders and ADF will use in the field. Just as we need the AI itself to be transparent and verifiable, we need our solutions to deliver that as well, and that must be ingrained in the way we work as an ecosystem.
Working with industry during the development of RAS-AI could help Defence understand the values and assumptions that go into the creation of a system. In the striking blind scenario, blind trust and a lack of understanding of the system resulted in a catastrophic error.
In our scenario, the system had always been correct. We did make it so that they had trusted the system, and that was a part of building that, is that they made the decision that they made because previously the system had always given the right information and given the right targeting information, so they were able to trust it. When they didn't have the full information, they trusted that the system did have the full information, which is why they trusted it when they did, despite the outcome.
So at the other end of the spectrum, when it comes to AI, the users of AI, they need to test that AI to failure. So in the striking blind scenario, Charles was conditioned to have confirmation bias, to trust that the AI's recommendations were going to be correct and that they were valid. Unfortunately, during the training that he received, he was never required to question the AI or to reinforce that what scenarios he needed to question the AI more than other scenarios, which then conditions people to trust or overly trust the AI's recommendations rather than to critically assess them. One of the problems when it comes to AI is AI increases the speed of decision making, or has the potential to do so, but the human still needs to critically evaluate that. If you just rely on the human critically evaluating every single decision, then you nullify the benefits of AI in that speed of decision making cycle. Within striking blind, the trust dynamics between the pilot and the AI, to push that point even further, the pilot needs to be conscious of every time that they are just accepting what the AI is giving them without critically evaluating. And within that, not only the pilot, but the entire kill chain involved also need to be able to look at the data that AI has recommended their decision based on. Within striking blind, without looking at the learning loop of the AI, if it has engaged a target, it's then been confirmed to be a legitimate target based on a pattern of behavior. If that AI learns within that short period of time, but the rest of the system or the humans involved in that system haven't learned in that time or don't understand how that AI has reinforced that decision making, then they can't test and adjust future assessments, which is what happened for that second strike.
Trust is a relationship comprised of competency and integrity. Competence requires skills, reliability, and experience. Integrity requires good character and professional competence. When RAS-AI is used in defence, operators will hold different levels of trust in a system, depending on how the technology fulfills those components of competency and integrity. To evaluate the competency of a system, we need to understand its limitations. Legal review can assist with this. Damien Copeland is a Senior Research Fellow in the University of Queensland Law and Future of War Group. Damien's research focuses on the application of export control, arms trade and sanctions regimes relevant to the export and brokering of trusted autonomous military systems and associated technology.
Any technology is going to have limitations, so any operator who is responsible for the use of an AI system must understand its capabilities, but also the limitations, and therefore be able to use that knowledge to use the AI effectively. Will be gained from a thorough test, evaluation and validation process, which will endeavour to identify circumstances where the AI is not able to perform to the required standard, where the AI is susceptible to vulnerabilities, particularly from enemy actions or enemies' attempts to confuse the system. Before a commander's actually given an AI capability to use in armed conflict, then there needs to be a thorough understanding of what those limitations are. Those that are responsible for its use, both at command and operator levels, should be thoroughly trained and practiced in the use of the AI in the environment where it's anticipated to be used.
it is critical that personnel have trust and confidence in the systems they are fielding. Commanders in particular should adopt a trust with verification approach to ensure that RAS-AI are used ethically and lawfully.
I think trusting something that can potentially make decisions without any human input can be hard, but now through working with autonomous programs that collate and process data, I now trust those to process data without any input, whereas originally I would constantly track them and monitor them. Soldiers and people in general tend to distrust things that they don't know about, so time on tools, plenty of instruction, as well as running through constant continuation training can help build levels of trust.
Commanders are not going to employ tools in a high-risk mission which they do not trust. With the technology available to us now, where I would trust a RAS-AI system is in logistics and resupply roles or reconnaissance, especially under the control or supervision of a human being. I would also trust that the vision from a RAS-AI system can be used by humans to make good targeting decisions. In contrast, we know that with the tools available to us now, soldiers are required when we need to directly attack the enemy. The best support that we can provide to soldiers and commanders in using RAS-AI systems is experience and familiarity before they get to a challenging mission. So we need to get these tools into the hands of soldiers and commanders in barracks and on exercise, and that will make them most likely to make ethical decisions in the same way they currently do with their weapons. Like any tool, the team will begin to trust RAS-AI systems after they've seen consistent behaviour and worked with that system.
Trust is essential for people working in defence because they are trusted to do the things that are otherwise restricted in society. Similarly, RAS-AI used in defence needs to be trusted to work in high-stakes contexts. To be trusted, RAS-AI systems need to be safe and secure within our nation's sovereign supply chain. They must also operate reliably in accordance with their intended purpose. Trustworthy RAS-AI must be lawful, ethical and robust. Commanders and operators must be provided with pragmatic training that establishes how and when RAS-AI can be trusted and when they should verify it. Trust can be established through rigorous tests and evaluation, and then extended through hands-on uses of the technology in exercise and operations.